Okay, so we just talked about the sort of definition of the polar coordinate system, and you'll recall this sort of idea that when you've got some position that you're interested in, the way that you talk about what that position is what the distance is from the origin, or the magnitude of that vector r, or the magnitude of the vector, and also the angle that you need to go away from the x-axis in the counterclockwise direction in order to get in the direction of that vector, right? So this vector r is defined by its magnitude and also by its angle. So the question we asked was sort of, what are the unit vectors in polar? Let me first remind you what they are in Cartesian, just to sort of frame up what they are in polar. If you talk about a Cartesian coordinate system, right, we have two unit vectors, j hat and I hat, right? I hat is a unit vector of length. It's a vector of length 1, a unit vector that points in the direction of increasing x, right? And j hat is a vector of length 1 that points in the direction of increasing y, right? So length 1 is one characteristic of a unit vector, and the direction is the direction of increasing whatever coordinate it is that you're associated with. So I hat is the coordinate, so x is the I hat, the coordinate associated with I hat. Well, if we think about that for polar vectors, it seems like r hat would be the vector of length 1, direction of increasing r. And theta hat would be a vector of length 1 that points in the direction of increasing theta. So if we look at this particular point right here, and we ask the question, what direction will we need to walk in to increase r, or the magnitude of the vector? Well, we need to walk in that direction, right? So this would be the direction of r hat. R hat would be a vector of length 1 that points away from the origin. And similarly, theta hat, if we wanted to increase theta, well, instead of walking away from the origin, we would walk in this direction, sort of counterclockwise. So theta hat is a unit vector that points in that direction. You notice that it is normal to r hat, right? You're either walking away from the origin or you're walking sort of along the sort of tangent to the circle that the vector r sits on. So, okay, that makes sense. You can define r hat and theta hat for that point. But notice something interesting about that. For this particular point, r hat points in that direction and theta hat points in that direction. But if you ask the question, what about this point over here? Well, for that point, what's the direction of r hat and theta hat? For that point, r hat, again, points away from the origin, right? So that's what r hat looks like there. And theta hat points in the direction of increasing theta, so theta increases counterclockwise, so theta hat would point in this direction. If I were at this point on the y-axis, r hat would point in the negative y direction, and theta hat would point in the positive x direction. So there's something pretty peculiar about unit vectors in polar coordinates as opposed to Cartesian coordinates, right? In Cartesian coordinates, whether I'm here or here or here, in each case, I hat points to the right, and j hat points up, right? The direction of the unit vectors does not change as you move around in space, right? In the polar coordinate system, that is not true. The direction of the unit vectors depends on where you are. And that's a pretty important idea. And it ends up having all kinds of interesting implications, because when you start to talk about things moving, that means that not only is the magnitude of the vector changing, but also the unit vectors are changing. And that can both be very handy because it allows you to collapse a lot of information into unit vectors, and also very confusing because a lot of information is collapsed into unit vectors. All right, so at this point we've defined the polar coordinate system, we've defined the Cartesian coordinate system, we've talked about what the unit vectors are for both of those coordinate systems. let's try to make a connection between those two coordinate systems. And I think we'll do that connection between polar and Cartesian in the next video.